So these are the notes for 4.7, completing the square. So we're going to find solutions to quadratic equations by completing the square with a leading coefficient of 1. Okay, here we go. Now, this is actually the third way of solving quadratic equations. The other two ways you have learned before is factoring and taking the square root on both sides. So let's kind of talk about both of those really quick. So you've done factoring. That's basically whenever you are able to factor a quadratic in the form of ax squared plus bx plus c. So an example would be probably like x squared minus 3x plus 2 equals 0. So if we were doing this, we can create our two sets of parentheses, have x and x, and then we know that the only two numbers that multiply to 2 are 1 and 2. And to get to a negative here, to add up to a negative 3, this has to be negative, and this one has to be negative. Then we would just set each of our factors equal to 0 and solve. So we can only factor if the quadratic equation is factorable, so we can get our value. So we get x equals 1 and x equals 2 as our solutions. Now the second way you've learned how to solve quadratic equations is taking the square root on both sides. So this kind of looks like whenever we do not have the x term or that middle term. So it might look like ax squared. You can have a plus c or a minus c and then equal to 0. Okay, so there is no x term. That's when we take the square root of both sides. An example of this would be maybe like this. We would have 4x squared equals 12. Well, to solve, know that we don't have a middle x term, right? Okay, so we just divide both sides by 4. So we get x squared equals 3, and then we just take the square root on both sides. So our final answer here would be x equals, now don't forget, plus or minus square root of 3. Since 3 is not a perfect square, and there's no perfect square other than one that goes into it. So completing the square is actually a third way to solve quadratic equations, and you can use complete the square for any quadratic equation to solve. Factoring, you have to use it for a certain type of quadratic, and taking the square root of both sides, same thing. So if we go back to our first problem, so we're going to solve x squared minus 12x plus 4 equals 0 by completing the square. Now you're going to see later on that, in fact, completing the square involves both factoring and taking the square root on both sides. So that's why you had to learn those two methods first, and then you're going to learn this method. Now, to solve by completing the square, what we need to do is take always the constant number and put it to the other side. So whenever we factored, as you saw our last example, we always have to make sure that's equal to 0. Or if we're taking the square of both sides, we move that over. Kind of similar to this. So every single time you complete the square, move the constant over to the other side. So now we have x squared minus 12x. Now I'm going to put a plus blank, and I'm going to explain why I'm doing this pretty soon. So, and then make sure you have put the 4 over. Now to put it over, we have to subtract 4 from both sides. Okay, so remember, whenever you bring something over, you do the opposite. And once again, we're going to have a plus blank. Now, what we're trying to do is, because as I said before, completing the square involves both factoring and taking the square root on both sides. So what we're going to do is make this right here what we call a perfect square trinomial. When we do this, this allows us to factor the left-hand side of our equation. Now, to figure out how to make this a perfect square trinomial, we're going to add a number to both sides of our equation. To know what that number is, we're going to use this little formula, and this is where completing the square comes into hand. We're going to use this formula of b divided by 2 squared. This allows us to put in the number on both sides of the equation. Now, b represents the number from our quadratic equation. So remember, in standard form, we have ax squared plus bx plus c. So b is the coefficient in front of our x term. If we look, it seems like it's negative 12. So that's what I'm going to plug into here. So I have negative 12 divided by 2 squared. So once I have that, I do negative 12 divided by 2 first, so what's in the parentheses. That gives me negative 6 squared, and then I plug that in. Now, make sure if you are plugging this into your calculator, you use parentheses around the negative. So negative 6 squared should give us a positive 36. So I add 36 to the left-hand side of my equation because now I have made this a perfect square trinomial, which allows me to factor the left-hand side. Now I'm also going to add the 36 to the other side because, just like you've heard before, we need to make the equations equal. Meaning what I add to one side, I have to do to the other. So remember that saying, what you do to one side, you have to do to the other? That's the reasoning. So since I added 36 to my left-hand side of the equation, I have to do the same thing to my right-hand side. It's kind of thinking about like in class. If I only gave the left-hand side of the class 36 extra credit points, it wouldn't be fair to not give it to the right-hand side, right? So if I gave both sides the same amount, it makes it equal, which works. So now what I'm going to do is I'm going to factor x squared minus 12x plus 36. So that means because our value, or a value for the x should be 1, this makes it a lot easier to factor. So I know I have x, and I'm going to figure out all the factors of 36. So we know 1 and 36, we got 2 and 18, we got 3 and 12, we got 4 and 9, 5 doesn't go into it, we got 6 and 6. So we need to figure out which pair will add up to a negative 12. Well, that should be the 6 and 6, right? If we have negative 6 plus negative 6, that'll give us a negative 12. So we'll have minus and minus, okay? So once I've done that, on my right-hand side, I just combine the like terms. So I do negative 4 plus 36. That just gives me 32. So now, notice here that both my factors are exactly the same. Because they're exactly the same, I can actually rewrite this as x minus 6 squared. That squared represents that there are 2 of the x minus 6. So that's why we want to make sure that we get a perfect square trinomial on the left-hand side, because we want our factors to be exactly the same. So whenever you use completing the square, you have to make sure your factors are exactly the same. If they are not, go back and redo your math. So now we have x minus 6 squared equals 32. So we've just done the factoring portion of completing the square. So now what we're going to do is do the taking the square root on both sides. So notice here we have a squared. Well, to undo a square, we need to take the square root. So I'm going to take the square root on both sides. Now this allows me the square root and the square, they cancel each other out. So I'm left with x minus 6 equals, and now since I've squared root of 32, we need to simplify that. Well, if we think about it, 32 is not a perfect square. But there is a perfect square that goes into it. And the biggest perfect square that goes into 32 is 16. So we have square root of 16 times square root of 2. So now what we want to do is take the square root of 16, which that should give us 4. And then square root of 2, we can't simplify that anymore, so we just leave it at square root of 2. Now remember, whenever we take the square root, don't forget the plus minus. So we get plus minus 4 square root of 2. Our last thing we need to do, because we need to get x all by itself, is we do need to move that 6 over. To do that, we're going to add 6 to both sides. And so I'm going to add it to the end, because this is not an imaginative or a complex number, so I can add it to the end. So my final answer is x equals plus minus 4 square root of 2 plus 6. Now, we don't add the 6 with the 4 because they are not like terms. The 4 has that square root of 2 attached to it, so all we can do is actually just add 6 behind the 4 square root of 2, or we could add the 6 in front of the plus minus. So both ways would be the same. But just remember, if they are not like terms, you cannot combine them. So this is another way of writing it. Okay, let's go ahead and let's try another problem. So once again, we're going to do x squared minus 12x plus 50 equals 0. And what we're going to do is solve this by completing the square. Now, in order to do that, our first move is to move the constant over to the other side. So to do that, I'm going to subtract 50 from both sides. Once I've done that, I just rewrite. I have x squared minus 12x. Now, just like as I did before, I add a blank, and this blank represents my perfect square trinomial. And then I have negative 50 plus blank. So now what I do is I use that formula, b divided by 2 squared, to complete my perfect square trinomial. So remember, your b value is basically the number right next to the x. In this case, once again, it's going to be negative 2. So I have negative 2 divided, or sorry, negative 12. So we have negative 12 divided by 2. That's our b value. And we square it. So that gives us, once again, negative 6 squared, which should give us 36. So just like last time, I add 36 to both sides. And when I add 36 to my left-hand side, I have made it a perfect square trinomial, which allows me to factor it. And so remember, what I do to one side, I have to do to the other. So if I added 36 to the left-hand side, I have to do the same thing to the right-hand side. So now I factor x squared minus 12x plus 36. Now when I do this, I want to make sure that my factors are exactly the same. So whenever you are factoring, the numbers should be exactly the same. Now we already factored this. It was the x minus 6, right? X squared. And that'll equal. Now we do negative 50 plus 36. That gives us negative 14. From here, I'm going to take the square root on both sides, because that's our next step. And then our square and square root, they cancel each other out, so I have x minus 6 equals. Now, notice here we have a negative, and we're taking the square root. Remember, whenever we have a negative, we replace that with a I. Now, 14, if we look at this, right, it's not a perfect square, and there isn't a perfect square other than one that goes into it. So we still just have square root of 14. So square root of negative 1, we replace that with an I. Remember, the i's always go before the radicals, and then we're left with square root of 14. Now, don't forget, we need the plus minus sign. Whenever you take the square root of any number, always have the plus minus. Okay, I'm going to scroll down to make sure you have this stuff written. There we go. Our last step is we need to move the 6 to the other side. To do that, we're going to add 6 to both sides. Now, because we have an I, remember, we need to write our final answer in standard form. This is what we do whenever we have complex numbers. Complex numbers usually indicate that we have an I, or imaginary. So since 6 is our real part of the complex numbers, we do 6 plus minus I square root of 14. And then this will be our final answer. Okay, I would like you guys to go ahead and try the next one, x squared minus 10x plus 8 equals 0. So go ahead and try to solve that quadratic equation by completing the square. And when to do that, make sure you pause the video. Okay, so hopefully you pause the video, you try to solve this quadratic equation by completing the square. If you got stuck, no worries, we're going to now go over this. Okay, so just like the past two times, we need to make sure we bring the constant over to the other side. So what we're going to do is subtract 8 from both sides. So that's always your first step. So we have x squared minus 10x plus blank equals negative 8 plus blank. Okay, now from here, we need to make the left-hand side a perfect square trinomial. To do that, we need to use the formula b divided by 2 squared. So we look at our quadratic equation. A is in front of the x squared, b is right next to our x. So in this case, our b value is negative 10. So we're going to evaluate negative 10 divided by 2 and then square that. So we get negative 5, and then we're going to square that, which should give us 25. So I'm going to add 25 to both sides. And so when I do that, on my left-hand side, I'm able to factor because it's a perfect square trinomial. So now what we need to think of is all the numbers, right, that multiply to 25 and add up to a negative 10. So we have 1 and 25, but I don't think that's going to work. And then we have 5 and 5. I think that's going to work the best. So here we have x. Now to kind of help you out, if there is a subtraction sign in front of your b value, then your factor is going to have that same sign. So we're going to have minus, and then because 5 times 5 gives us 25, and we have negative 5 plus a negative 5, that gives us our negative 10. So we have x minus 5, and because the factors are exactly the same, we can write squared. Equals, and then we're going to combine our negative 8 plus 25. That'll give us 17. So we did the factoring portion of our completing the square. Now we're going to take the square root on both sides. So now we get x minus 5 equals. Now we look at square root of 17. First of all, 17 is not a perfect square. And there's really no perfect square other than one that goes into it. So we're just going to leave this as, remember, we used the plus minus sign, plus minus square root of 17. Now, every single time we take the square root, make sure you do plus minus. Okay, now I'm going to scroll down, so make sure you got this top portion all written down. Now, our last step, what we have to do is move the 5 over. So I'm going to add 5 to both sides. So I get x equals 5 plus minus square root of 17. Or you could write it as plus minus square root of 17 plus 5. So because there is no imaginary numbers, we can either bring the 5 before the plus minus or after the square root of 17. And either of them work. So that would be your final answer. So if you do have any further questions, make sure you email me, or you can go to any math teacher along the hallway to get help. Now, I do want to do one more problem, which is not on your notes, so you might have to just make some room for this, okay? So, we're going to go back. There's your homework. It is a worksheet, okay? Okay, now let's say we get this as our final answer. I'm just making something up here. So we have x, I'm going to make this a plus 4 equals plus or minus 9. So let's say we got this as our final answer after completing the square. So we did the factoring, we took the square root on both sides, and we got this answer. So in this case, like we've done before, we would move the 4 over, in this case by subtracting, all right? Now notice that your answer here, the plus minus 9, 9 is an integer, as well as the minus 4. Because they are like terms, we can actually combine them to get our final two answers. So we get x equals, so notice that plus 9 is another way of saying positive 9. So we have positive 9 minus 4, and that will give us one of our answers, 5. Okay, if we do it for the other one, so minus 9 or negative 9, we can have negative 9 minus 4. And if we combine these two, that'll give us negative 13. And so our final two answers here would be 5 and negative 13. So whenever you have two integers, make sure you combine those two to get your final answer. And to do that, realize that 9 is both a positive and a negative, and you're going to subtract that from 4. Okay, so make sure you know how to do this because there are going to be some problems like this on your homework. Once again, your homework is a worksheet and it will be due the next day. So if you do have any questions, email me, or you can ask any of the math teachers along the hallway, either before or after school, if you need some extra help.